In the previous lectures, we have discussed about gray code encoding, bus inversion encoding, okay, and other encoding techniques are also available. Here you'll be having like one hot encoding. One more encoding technique is remaining, that is T0 encoding. In the T0 encoding, we'll be having zero Hamming distance to be maintained. That means you need to transmit the same data, that is there are no transmissions in the data before encoding and after encoding, but you'll be having a bit indicating either the received data to be increment or not. T0 in the sense there is no transitions, zero transitions after encoding and before encoding. How it is possible? Let us say you have transmitted a data given as 0 0 0 0 0 0 0 0. If I want to transmit the next data, all zeros followed by 1, and the next data will be 1 0 1 1. What are you doing here? Just incrementing. Okay, here you are incrementing the things. 0 is incremented to 1, 1 is incremented to 2, 2 is incremented to 3. Addresses are successive locations where you can transmit them by a increment fashion. Okay, first of all, I will transmit a data. I will transmit this first pattern, all zeros, and if my next bit is having, let me see here, let us consider this. If b t minus 1, that is previously transmitted bit, is having a condition that in the previous form it is called as b of t, it is equal in such a manner that only one bit, only one time increment has been done in the location. If it is one time increment, then increment bit is made 1, else increment bit is made 0. If it is one time incremented, increment bit is made 1 and the same bit is transmitted on the data bus. If you don't have the same scenario, it means that if you have any bit changes in this region, the first condition says that whenever you are having previous data correlated with the next data in such a manner that there is only one time increment in its value, then you can transmit the same data, say increment by 1. Then receiver will increment the data. It will be receiving the same data without any transition, it will be receiving, but it will be having an increment option there. If there is some disturbance in this data, then you will not be transmitting the same data, you will be transmitting the new data. That new data is named as B of T. The increment is 0 whenever you are transmitting a new data. This is considered here. See, by comparing the data values, if you are having a one-time increment, then the same data is transmitted and increment bit is made 1. Here the number of bits is n minus 1. Comparing to previous encoding technique, here what is advantage is, as the n value is increasing, then also your switching activity is made 0. Whatever may be the n value, the number of bits you are transmitting, either it is a 2-bit, 4-bit, 8-bit, 16-bit, okay, you'll be transmitting the same data. Just you'll be incrementing the data by 1. Okay, that is T0 in the sense it is having 0 transitions on the data bus encoding. Okay. Conclusion is, let me have a brief conclusion. Yeah, you have encoding techniques. Encoding techniques are of two types: redundant encoding technique and non-redundant encoding technique. Based on your m and n values, we may have the type of encoding technique. And For each type, you have specific code. Let us consider encoding technique, non-redundant and redundant. Here you'll be having m is equal to n. After encoding, also you have the same bits. Best example is gray code. And here you may have m is not equal to n. Here you have two types like static and dynamic. In the static, you have the requirement of memory at decoder, whereas in dynamic, you require memory at both encoder and decoder. Okay. In the gray code hardware implementation, there is no memory requirement. In one hot encoding, you require memory at in one hot encoding also it doesn't require, sorry, one hot encoding, you don't require any memory here. Whereas in bus inversion encoding, you require memory at the encoder. Uh, at, at the encoder, you require the memory. Whereas the last type, like T0 encoding, you require memory at both encoder and decoder. These are the simple encoding techniques. You can refer the notes for still detailed explanation. Since the video length is very less, I need to conclude here itself. If you have any doubts, you can ask me through my WhatsApp number, which is present in your college group. Thank you.